Okay, so Pascal's triangle helps you with this binomial process. So you can always write it down from memory. It's not a big deal because you just start writing ones, right? And then these came from, you guys already figured out where they come from. They came from going, okay, 1 plus 1 is 2, and this one came from, excuse me.
Yeah, I was like, what?
1 plus 2 is 3. 1 plus 2 is 3. 3 plus 1 is 4, etc. And you can keep going. You don't need to keep going unless, depending on what your problem is. So you guys, when you have this kind of a problem like x plus 2 squared, or we have this a lot, x plus h squared, how do you do that? What do you get? That's the shortcut that we know now, right? That comes from right here. 1, 2, 1. So these give you the coefficients at least for
So then if
making any
something
kind
was
of
cubed, would it be
expansion.
1, 3, 1?
Exactly.
Or 1, 3, 3, 1?
So we had like x plus h cubed too, and you guys had to write it all out and combine like terms and yuck, yuck, yuck. But watch.
Told me there was no shortcut last
You lied to you.
So how do you do this one? Well, you know it's going to be what, Austin?
1,
You know
3,
the coefficients are 1, 3, 3, and 1. And now you just fill it in. So watch how you can fill that in for x plus h cubed. You go x cubed, and then you just walk down. This is x squared, this is x, and this is really x to the 0, but you don't have to write
That one's 8.
That's just 1, right?
Never mind.
Then you take h, you start on the other end, and you walk up. So this is h cubed, h squared, h, and h to the 0. And you put pluses in between, and there's the answer.
Why are you just telling us this now?
No, I'm not perfect.
I'm just
I've
kidding.
been teaching
I
like
was
3 years,
joking.
man.
I was joking.
I do now. Okay, so x plus h to the 4th, it would be terrible to do that by hand, wouldn't it? It would like take forever. But if you know this, you can just write those coefficients down, walk back up, it's done. Okay, I think that that kind of a thing is going to help us with this problem. So Pascal's triangle gives you these coefficients. There's other ways to get these too. It's called a choose in combinatorics of probability. Okay, but that's not going to be super important for our problem. How can we use that to help us on this next step? So, okay, I'm going to write it so we can get it in the video. We have this problem. So I think we can expand this out just like we were doing on those. Okay, so how can we do it? What's the first thing that we're going to get? X to the n. Excellent. Any questions there? It's going to be x to the largest power. So then what's the last thing that we're going to get? If we expand it? H to the n. And those are both going to for sure have 1s on them, aren't they? Based on what we did over there, no matter what, no matter how far we go. This doesn't tell us where to stop. It says n. N could be anything, right? But no matter what, no matter where we stop, if we stop here, 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 those first things are always going to be 1s, and the last things are always
So
going to
then
be 1s.
would you just put...
And then no matter what, your x ends will cancel, won't they?
Yes, good.
What?
So we've accomplished this. We have minus xn when this carries down, so we know that our xn is going to go away. Nice, exactly, right? So we're starting to think about, oh, this is going to work out. So the question is, how do you know how much to stop? Well, you don't really, do you? But you can at least think about it a little bit and put in a couple more terms. So this next guy would be something. We don't know what that number is. It could be a 3, a 4. We don't really know what it is. There's a mathematical way to write it out. So let's just leave it blank.
What,
Okay.
is that the mathematical way to write it out?
No, but it's going to be blank x to what power?
-1.
X to the n minus 1.
Yep. I don't see
N
that.
minus 1. Okay, and then what else is going to be attached to that? You're also going to have
H.
You're also going to have 1h, aren't you? Just 1, for sure. No matter where you stop, you're just going to have 1h. And then the next thing would be plus
Something.
Something.
H to the n minus x. H
N.
to the n.
X to the n minus 2 times h squared. Let's make this bigger.
Wait.
Let me write it out a couple more times.
Yeah,
So
'cause
plus
I mean,
something x to the n minus 2, we're walking down, and then h would be squared this time, okay?
wait.
Now we don't know where to stop, so let's just, okay, let's put plus dot dot dot.
Wait.
Okay, and then we had over here, let's start at the end. We had an h to the n, correct?
So you're going to have
let's go this way. Plus h to what power? If we're going back up.
The n minus
N minus 1, and what's x here?
just x.
Just x to the 1 power.
And then there's a something.
And then we could go, okay, let's do one more here. So plus h to the, Kyle, can you help me? H to, yeah,
And h to the minus 2.
yeah, great. And what about x? Somebody else? X squared, right, he says, okay. Plus, okay, so then we're gonna have, no, we don't know what these coefficients are, right? Again. But this one's gonna be the same as this one. And this one's gonna be the same as this one for Pascal's triangle, right? We don't know how those are. Okay. And then we said, okay, well, I gotta put this back on, don't I? We had that down. And it's all over h. Now, Anna, you told me what to do next. Approve.
Get rid of the
Cross
x.
out your x.
Now the question is, does it matter what those blue things are? Yeah, it does, but I'm not gonna go over that.
Todd, how are you not writing this down? I don't understand how this is possible.
That goes there. Cool. What's left? Let's write it. So we've got blue thing, x to the n minus 1 h, plus some other blue thing. It's not the same thing, but x to the n minus 2h squared plus dot 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 plus x squared, I have a blank there too, x squared h to the n minus 2 plus, I'm going to leave these in black.
I don't understand. Why did you go from n minus 2 to n minus 1? Because you're walking, like... no,
N
there.
minus
No,
2,
no, no.
n minus 1, n
2
minus
is
2.
smaller than n minus 1. Remember
I know, like, why'd you go 1, then 2, and then here you went 2, then 1?
I'm walking this
Because that was the rule of the x's. Remember the x's?
biggest,
Oh, the x's,
next
so the
x's go.
biggest, next biggest, next
Oh,
biggest,
okay,
next
because the
biggest.
h is...
Cool.
Yeah.
We haven't done this kind of an argument before, so it's a little bit new, right?
Well,
Okay.
all of these terms will have h's in them, so h's will cross out, which means h crosses out.
Isn't that what we do next? Why don't we usually factor out an h? Yes. So can't we pull this out and say what's left? We've got blue thing. I'm going to fill in these blue things now. I'm not showing you where they come from, but that blue thing is n. Okay, this blue thing is n. This blue thing I think is n minus 1 over 2,
Wait, I can't.
and it starts to get messier and messier. So x to the n minus 1, we pulled that h out, right? It's gone. And Anna says, okay, if you pull one h out here, what's left? Another h, so we've got n minus 1 over 2, x to the n minus 2, and an h. So we pulled one of those h's out, plus dot dot dot, plus whatever this is. I think it's going to be the same as this, isn't it? How many of these h's are left? H to the, ooh, this is tough factoring. H to the n minus,
Oh, no, minus.
or is it n minus 1?
I don't understand how it is.
That's just representing what we don't know.
Yeah, just hold on. H to the n.
Minus 2. Oh,
Shouldn't it be
I thought
n?
we were still. Yeah.
Isn't that going to be it? Think about it. If you're unsure, we're supposed to get h to the n when we go back, right? If we take this guy and we go h to the n minus 1 times h to the 1, we take it and put that back, that h we factored out, we put it back, what do we get there? H to the negative 1 plus 1 is, that's why I'm getting that. Okay, that's tricky though. Good stuff. Okay, the whole point of doing this, Anna, what was it again?
Well, and now, yeah, or an h.
That's what we always have, that's what we always try to have happen in our limits, right?
I don't understand where you got the 2 from.
What, 2?
The 2 over 2. No, the next one. Yes.
You shouldn't.
Okay.
I could explain it, but we're not gonna sit here and go through that. Not as necessary, so good question, Austin. I hate it when teachers tell me that, but we'd have to sit here for another 15 minutes, we don't have time. We don't need that for any purpose this year. Okay, so now when I put h equals 0 in, look at this. I'm not gonna write it all out again, okay? So let's just put it in. That means anything with an h in it goes away. It all goes away, but not all.
into the x.
Does this have h in it?
No.
Oh my goodness, that doesn't. This has an h right there, so because of this guy, this whole thing goes to 0. Because of this guy, this whole thing goes to 0. Same thing with this whole thing, and same thing with this whole thing. Cool.
Okay, so this was
All that's left is,
Oh, all left is NX. Oh, and that's it.
Hold on.
there's the proof.
I don't exactly see it yet.
It's in the
Neat, huh?
living.
So in the end, everything has an H besides the first part.
Yeah, exactly. It's the first thing that makes an impact.
Why do those go to 0?
All
You
have
get
an
the
H,
limit.
and as H approaches 0, so you substitute all the H's for 0, but the first part is the only one that doesn't
If
actually.
you're thinking about it, could you just pull down the end? Then you have to
Yeah, you wouldn't have to write out this whole expansion to get this, right? You could only write out like the first couple, the first term, maybe one or two more of the other terms, maybe even just the first term, and then if you understood that all those other terms had an H in them, you could do this in your head.
I don't understand when people like discovered this.
That's about all.
Like the first person who found this.
Oh yeah, how did they?
Oh, I don't think this would be that hard.
No, like, yeah. Okay.
Every person who's a PhD in college, this would be like child's play. And every person with a master's degree in math is child's play too. So unless they have a very
Unless
bad
they're Mr.
master's degree
Gallant.
or something, I don't know. There are bad ones out there these days. So okay, let's see.
And now we're starting our now.
Okay, we're gonna go to 2-3.
Yeah,
Okay, so
200 page proof. Would you hate to be that astronaut?
oh, it's so much fun. Okay,
No, you'd be like,
so-
would you check your math?
product and quotient rules. That's what we're gonna learn in this one. And I have the proof, the product rule that we're gonna do. Since we saw that big proof today, I think we'll see the other one tomorrow. We don't wanna overload you guys. So let me just tell you what these rules are, and I'll prove one of them tomorrow for you. So the derivative of f times g. So we had a couple problems in our last assignment, and you distributed to avoid having to do
Why
this.
don't you have a dy? Just have
D this.
Oh, d
with
that.
respect to x.
It's just.
Good question. So we're going to do that one. We're also going to do this one. Okay. So these are the two rules we're going to learn for this assignment. That's it. Well, actually, there's a couple more. Okay. So what happens when you have?
So is that like derivative
Product.
of f of x times derivative of g of x? Is that what we're saying, or what
Is
are we
it?
saying by that?
Do you get f prime times g prime?
Okay, so that's what we're trying to find right
Yeah,
now.
I'm trying to figure it out. Yep. So this is what you get, and I'll prove it tomorrow. But it turns out that you get, first thing, leave it alone. Multiply it by the derivative of the second thing, so g prime. Then you got to add, leave the second thing alone, and multiply it by the derivative of the first
Does
thing.
that have something to do with the like if you have something times like a constant times f of x, you find the derivative, you would get the 3 and the derivative of whatever f of x was.
Yeah, but I think we're really going to have to look at the proof tomorrow to understand it. But that's how it works. That's the product rule. One thing times the derivative of the other, and then you just do what you didn't do. So plus the other thing times the derivative that you didn't do yet. Does it really matter which order you do this in? It doesn't, because there's a plus in there, right? So this one I think is very easy to use still.
So
it's
is
a
the
little
next one
longer.
just a minus?
It has a minus, yes. So this one you go G. It's half to, this one's more particular. Quotient rule says you take the bottom, you do times the derivative of the top. Then Austin, you think there's going to be a minus, so it doesn't matter which order you do it in. Then you take the top times the derivative of the bottom. And it's all over the bottom thing squared. So the quotient rule is kind of a pain, so usually we try to avoid using the quotient rule. There's a nice way to remember it, because you need to memorize these both, of course. This one is really easy. This one, you have to have the order real precisely. Okay, so I like this. I think, let's think of this as pi and ho. This is everybody's favorite calculus little memory acronym. So it's ho. Think clever. You couldn't say high prime, but what else could you say?
Snow White.
You could say ho.
That's just literally what I think of.
Yeah.
Hody high minus
Heidi ho.
Heidi ho.
What is the D
Over
stand for
whole
exactly?
Derivative.
Oh.
Very improper notation, but it helps you remember. Over whole squared. Think home improvement. You've got this, right?
Heidi ho, neighbor.
Exactly. So Hody high minus Heidi ho over ho squared. That is the quotient rule.
Okay.
You can remember it that way or this way. I don't know. I think that's fun.
Am I the only one that got the home improvement?
Nope.
one?
No one's
I didn't get it.
Come on, Wilson's always like, Heidi ho, neighbor.
We didn't have TV in my childhood.
That sucks.
That's not even your childhood. That's like.
Now again, you got rid of it again.
In my
I
car.
would hate that.
No, that's
It's
like
actually
even
not
before
so bad.
you
You can get a lot of reading done that way.
I hate reading too, so.
Mr. McGee, when is this assignment going to be due?
I haven't decided.
Okay, just because I was just
Not
wondering because we have a lot of tests this
And
week.
is the carnival
Yeah, I don't have any
right?
I have a chemistry and an AP US history test on Thursday.
Oh.
And carnival and
We'll see. Okay, let's do those two first. So we need is product rule or quotient rule on those. What do you guys think?
Product rule on the top.
Thinking product rule stuff. Yeah? Okay. So let's do H prime. So I'm going to take the first thing. I'm going to multiply by the derivative of the second thing. What's the derivative of the second thing?
4.
Yes. 0 plus 4. 4. Plus, now take the second thing. Leave it alone. Multiply by the derivative of the first thing. What do you get? 3 minus 4x.
wait, so that's the derivative of
First
that.
thing, derivative second thing, plus second thing, derivative first thing. You can do it backwards if you like. You don't have to remember it in a specific order. You just
Why-
gotta remember a derivative and an original, a derivative and an original when you do both parts. Okay? Then you simplify this and see if we can simplify it. So I get 12x minus 6x squared. Oh. Jeez. Plus,
You did this
I'm gonna have to
yourself.
expand. 15. I got a 12x. I got a negative 20x, and I've got a negative 16x squared. So if I simplify this, the reason you might need to simplify, why does it matter? Why can't you just leave it like that? What if you need to take another derivative? And that's very, very, very common. So I'm going to combine my like terms, and I've got 24 minus 20,
Oh, there you
So
go.
4x.
4x, and I got a 15. There is H prime.
That's
Okay.
how you use the derivative after you use it over. Finding the velocity or something. We use this. Ah, I feel better. I was trying to figure that out earlier.
Okay, let's try this one. This, I'm going to have to use what?
This.
Product rule. This is just take derivative right away, right? So this has like a product rule and something else in it that's real common too.
Okay, hold on.
So I've got to go, okay, first thing, what's the derivative of cosine? Negative sine x. Plus, second thing is cosine x. Cassidy derivative of the first thing is 2.
Mister, will you move your hand really quickly?
Okay, so I did all that. Then I've still got this part. What's the derivative of sine of x? Cosine of x, so that's minus 2 cosines.
And then you have a minus 2 cosine
Wait,
plus 2 cosines.
where do you get the cosine x2? The plus cosine x2, where'd you get
First
that from?
derivative of second. Plus second derivative of first. Okay. Now Caitlin's saying that 2 just goes here, right?
Oh, okay, that.
And she's saying, oh, those are the same thing, they just go away. So if I wanted to take another derivative, I'd hopefully spot that, because this is going to be much easier than all that other junk. Okay. Shall we see one with the quotient rule? Sure. Yeah, let's do one. maybe have you guys try it before I say it. Okay, so let's say we've got, this is y. So this is the kind of problem I don't really like, but they'll certainly ask us about this on the exam, at least once. And you need to be able to do this. People can't do this, can't do calculus. Okay, so find the derivative of that for me, please. Try to use Mr. Wilson's
Wait, is it Hody
quotient
high or
rule
Heidi
method.
ho first?
Hody high.
Got it, because I was thinking about the quote, I was like, Heidi ho, but that's not, okay.
It's in there, but it's Hody high
Yeah,
first.
Okay.
Hody high minus Heidi ho over ho squared.
So it's
Lots of parentheses are going to be used, I think.
so this would be for 5x minus 2,
Mm-hmm.
the derivative is just by 5, right?
Yep.
Okay.
So that part's going to be easy.
Whole thing's
Still
easy.
just a bunch of long algebra. It's not hard. It's just long algebra.
Do it right. It's a miracle. Wait, I don't know what's for that. X squared is x to the 4th, right? So did you get 2x to the 4th plus 2x squared? Oh, okay.
I think I will make this assignment maybe Monday. Give you guys a break.
Thank you.
Okay.
Thank you.
But we'll also have our first derivatives quiz on Monday. So we're going to practice our derivative rules. So we'll have 5 or 6 quizzes. The first one will be Monday, 5 problems on any rule that you've learned up to then.
Is it worth like test grade? Like it's
It's test points, but small amount.
yeah, but it's still like the 70% of our total grade or whatever.
I think these are a good way, actually. You should be able to use them to get your grades up there.
I hope so.
It'll be Monday.
Yeah, Monday. I'm going to teach you some more derivative rules tomorrow. We'll have almost all of them by tomorrow. About 2/3 of them we'll have by tomorrow.
Well, did I do it right on top? Negative 5x squared plus 4 is plus 1?
I got plus 9. Did you just put your 5 here?
Yeah, 5x squared plus 5.
Oh, so is that?
Yeah, it should be 5.
Yeah, I got that.
But,
Yay!
2x to the 4th plus 2x.
Well, this is the stuff that I showed you gave to
I
me.
know where plus I know where he got it from now.
I see.
Oh,
All do the
gosh.
same thing.
Oh, yeah, I forgot the 1. So, over, what did I say was over? Just x to the 4th or 2x to the 4th? Oh, yeah.
So I got. Did you expand that on the bottom? Sure.
I did.
Depends on your goal is. Well, that's good practice. It's good practice to try that then. So we'll be doing stuff with this soon. So the question is, what do you need to do with it, right?
So, will we end up getting something that like canceling?
Yes,
Okay.
sometimes.
And that's the answer, we're done?
Yeah. Okay, that wasn't bad, was it? Yeah, didn't think so. Alright, let me put your assignment on the board. I'm going to show you a bunch more stuff tomorrow. So I'll prove the product rule tomorrow, and I'll also show you how many of our 6 trig functions do we know the derivative of.
3. No, 2.
We know sine is
Cosine.
cosine.
You just know sine and
You
cosine.
could probably take that to
There's
find
4 more.
tangent, can't you?
Yeah, could you
Yeah.
find
You
tangent
could
that
use
way?
it to find tangent.
You can. Yeah. Maybe that'd be interesting to look at.
Well, because sine.
It'll be
Well, because sine, does it sine equals cosine?
times all that. And cosine equals negative sine. So
Yeah.
tangent
Would
would
be
be
cosine
over
negative
negative
sine.
So it's the negative cotangent.
I
We're
mean,
gonna go to step with a pair.
Oh,
Like
it
it's
is.
really hard.
Close.
I'm so sick of her hair. Who are you doing? Caitlin. I'm still gonna do Gaga, but I'm gonna wear the swimsuit thing. Sure. Like, I'll just wear something really weird. I'll still do like the weird lips, like the thunderbolt eye. I don't know what I'm gonna wear.
Miss Me, why do you go 11, 18, and then 17?
It's really cool.
Just saying, because I know.
Baby size. You put your hair in there.
Okay, there's 2 problems that are of the most importance in this section. I mean, these are
20,
mostly
21.
mechanical, but
Oh, dang.
those 2 are the most important, very AP-like types of problems right there. Okay.
So, Mr. McGee, out of curiosity, what is the derivative of tangent of x?
Secant squared of x.
Oh, I said.
Remember, so how do you do all those things? You can think like that
You
in
put
patterns.
tangent equals sine over cosine, and then you take the derivative of sine over cosine, which is.
So we wanted to do it for tangent.
Yeah.
What?
So it'd be the tangent of.
Yeah.
As it feels like when I look down. Like when I get one more.
So then for all those trig ones, didn't we have identities that described this? And tangents was like the yuckiest identity, wasn't it? Look it up. Find it in the book. Let's do this one. So what is tangent? I just said it's secant squared. Let's see if we can prove it.
Hold on. So write this down in our notes.
If you want, it's up to you.
It's gonna be useful.
Tangent of u plus or minus v is tangent of u plus or minus
So we got tangent of x.
x plus tangent of h
We did this last year.
over 1 minus,
Minus tangent
tangent
x,
of x
tangent h.
tangent of h minus tangent of x.
So this one's ugly.
That's really
I can't see
ugly.
it.
Now what do you guys think we'd do?
You would find a common denominator
I'm thinking
and then
that.
pop the h in the bottom.
Yeah.
Or discriminate against it.
What's that mean?
Let's hope we can get to it. I don't remember. I haven't done this one for a while. So put the h in the bottom. This guy's got the right denominator. Oh, what do I need in front? I'm just gonna write
The
lim.
limit. Because you'll get in
Lim.
trouble for leaving that.
Yeah.
You will. The math gods. They might interfere. So then we'd get, when we multiply that up there, we're gonna get a minus tangent. Ooh, I'm happy. Minus tangent. And then this thing's gonna be yucky. Plus, ugh. This times this is plus tangent squared of x tangent h.
It's really gross.
It is.
It's nasty.
Those go away.
Yeah.
Oh, I think I might see it.
You have a 1 minus tangent.
So we've got tangent h
I didn't do it. I know.
Stop.
plus tangent squared x tangent h.
It's like I pee over you and then clear head on.
I think we should factor that tangent h. Do we have an identity for that? Yeah, I think we do.
That's the secant squared.
We're definitely going to need this identity this year. 1 plus tangent squared is, well, there's our secant squared we were talking about.
You already told me this before.
I haven't.
Hmm.
calculator.
Oh, now this limit's gonna get intense from here. I don't think I'm gonna show you guys the rest.
That
I
bad?
think we're about 25% done.
Oh, it's gross.
Maybe 33%. I'm gonna stop. But you can see secant squared is gonna pop out. Somehow you're gonna have, like, when you start distributing these and these, you might end up using those special limits that are like the sine of x over x is 0. And some of those things will start going away if you keep taking it out. But I'm not gonna show it. It's cool though. I don't want to freak you guys out too much.
I'm already freaked out. My mind's not working
You
anymore.
don't need to be able to do that.
Just stop.
I may assign 1 or 2 of those as extra credit for the next week. That would be a good one.
Oh, Mr. McGee, do you know what time his class ends today?
Anytime now. I think it's going to end in 5 minutes or less.
I'm not even
I'm not
sorry.
sure though, I really don't.
I think we can have, I want to say like 2 and 7.
Yeah, so that'd be a second.
Disgust me.
You know, changing homeroom around just messed up my entire day.
Yeah, I don't understand.
I'm serious.
Riley.
Huh?
This looks longer than actually is, because we're all single couples.
Did I do my lab this one?
Please don't.
Hey, Caitlin, are you okay? So you should take today.
Oh.
I know, like, it looks huge, but I don't normally mine are like down here. Like, oh good, I was reading your square this time.
Yeah.
There's an easier way to do this, to prove this.
Really, than what we did?
Just write it as a quotient, like you said.
Riley, I'll go down.
Yeah, the
and you
sine
guys
of
can't
x
make the
over.
word.
Sine over cosine is a quotient rule.
Oh, quotient rule.
So up or down?
You go up.
So I do more.